So Google's created a few pieces of custom silicon, ranging from the tensor processing unit for AI, which is very famous and everyone knows. But one of the lesser known pieces of silicon that they've sort of created for their own in-house needs is Argos. It's a completely new kind of application-specific circuit, right? It's a video coding unit, or a video processing unit, VPU, VCU. And the main idea behind it is that Google has very unique needs, or at least they have a unique scale with regards to how much video they ingest and then serve, and or photos they ingest and serve. And so they'll get video in all sorts of formats and resolutions from their consumers, uploaded to a number of their IPs like YouTube, Google Photos, Google Drive. They have to stream it back out to these users. But you don't just store the raw file and then send the raw file, right? Because what if someone needs to, someone wants the highest resolution and someone else wants, they have a limited bandwidth, or limited data per cycle. So they have to store it in many different formats. And at the same time, storing all this data across, the billions of hours of YouTube that are out there would be incredibly expensive, on a cost basis, right? Of just storage, of streaming, right? Data streaming is expensive, networking is expensive, storage is expensive. So they created a new ASIC called the VCU Argos. And the whole purpose is to encode video, right? And before they encoded video as well, but they did it with x86 Intel CPUs, right? They did it with Intel Skylake, and before that, prior generations of Intel CPUs. The problem with this is that the CPUs are much less efficient, especially when you start moving to more advanced video codecs, for example, VP9 and AV1, that save you on storage, save you on bandwidth, but involve a lot more processing to encode the video. And so these CPUs start to hang up in terms of performance. You start needing so many more CPUs. It's actually a delta of millions of CPUs